This is the reality for millions of people in public health centers every day. In these high-pressure environments, every second counts. But when the flow of patients is disorganized, medical staff are overwhelmed, and the most vulnerable can be overlooked. Chaos isn't just a frustration, it's a barrier to quality care. But what if we could turn this confusion into a clear, fair, and digital path? We are Group NoName, and today we are presenting a solution that uses the power of data structures to bring order to healthcare.
Our project video will show a public health clinic or hospital with a disorganized system where patients are confused and not attended properly. Then we will introduce the Q or FIFO system as a solution. We will make it relatable by comparing it to our everyday situations like lining up in the store. So through simple visuals, we will show you how patients are placed in a digital line and being served one by one. So making the process more organized, efficient, and fair.
Technically, we are using the Q data structure, specifically FIFO or first in, first out. This is the best tool for the job because it ensures absolute fairness, no favoritism, no jumping the line. You are attended to in the exact order you arrived. This project proposal connects directly to SDG 3, Good Health and Well-being. By organizing patient flow, we reduce the stress on medical staff and shorten the waiting time for patients. Better organization leads to better access to care, which is a cornerstone of global health goals.
Overall, this project deepened our knowledge of how a data structure first in first out concept works in a real-world situation, specifically managing patients in a teleconsultation system. Rather than just learning the concept in theory, we were able to apply it by simulating how patients are managed in a organized and fair way. One of my main takeaways as we chose the first in first out queue structure is that it is essentially needed in systems where fairness is needed. In the said project, the first patient who enters or joins the system will also be the first one to be served, where this prevents confusions, avoids skipping, and ensures that overall, every patient is treated equally. We also learned how to properly structure a program using objects and data structures together. By creating a patient class made the system more practical because each individual has their respective data, while the queue manages the processing of the order. In relation to the chosen SDG, Good Health and Well-being, this project shows on how a simple data structure like queues can improve healthcare systems by organizing the patients in a fair and equal way. Even though this is a basic simulation, it also represents on how technology can reduce the waiting time confusion and improve the service efficiency in real-world medical settings.